this is 4.4 Transformations Day 2. We are going to be looking specifically at our logarithmic, exponential, and rational function or reciprocal function for our parent functions. And then we're going to be doing our transformations on those. Just things to remember: our basic equation, and then is it with x, then it's happening in the x direction. Not with x, then it's happening in the y direction. All right, let's look at our first example. Given f of x is 1 over x, write the transformed function, describe the transformations in correct order, and create the table of values and sketch the transformed graph. We have our g of x function here, so it equals f of x minus 5 plus 3. So that means we're going to substitute in for x that x minus 5 and then add 3. So our g of x is going to be 1 over x minus 5 plus 3. All right, so we have our minus 5 with our x. So remember that does the opposite. So we are going to go right 5. So remember, anything with x is horizontal, so right and left is the inside. And then on the outside, it's happening to the y. So plus 3, that's going to be up 3. So if we look at our parent function, we have the 1 over x. It has our asymptotes at 0, 0. So that's what's being moved to the right and to the left. So our asymptotes are the ones that move. We're going to go right 5 and up 3. So 1, 2, 3, 4, 5. And then 1, 2, 3. So our asymptotes will be here. And remember, and then they'll be in those sections. All right. From our parent function, we have 1, 1 is this point here, and negative 1 is this point here. And then you kind of go from there. So looking at our original set of points, so 1, 1, and negative 1, 1. Negative 1, 1. Negative 1, negative 1. There we go. All right, and then 2 is going to be 1 over 2. And then 3, 1 over 3. And then same down here, 2, negative 2, negative 1 over 2, negative 3, negative 1 over 3. That's from the parent function. All right, so let's graph these. I'm going to change the color here. All right, so right 5 up 3. So right 5 happens to the x, and up 3 happens to the y's. So we'll just add those here. All right, let's look at our points. So kind of at our center points, we'll have 6 and 4. So 6 and 4, that's going to be here. And then this one is going to be 4 and 2, which will be here. And then we'll go out from there. So then 7, 8, and then 3 and 0. And then we will have 1/3 plus 3. So we got to change this 3. So it's going to be 9 over 3. And you can do these in your calculator. So that's going to be 10/3. This one is 6 over 2. So 7 over 2. And then this one, 6 over 2 again. So that's going to be 5 over 2. This one will be 9 over 3. So 9 minus 1 is 8 over 3. All right. So at 7, we're at 7 over 2, so 3.5. So it's kind of there. And then we'll go here to 10 over 3. So that's 3 1/3. So getting closer to that 3 line. So it's going to go like this. And approach those asymptotes on either side. And then we'll do the same thing here. All right, so for that next point at 3, we have 2.5. And then the next one, I did change that. That's supposed to be a 2 and not a 0 because we were adding 5. And then this one would be 2 2/3. So getting close to the 3 line on the lower side. So it's approaching that line on that side. So approaching those asymptotes either direction. I can't get that line to cooperate. There we go. It's a little better. So that would be our graph. All right, let's look at the next one. So we have e to the x, and these points you probably will have to do in the calculator because e is a decimal number. It's 2 point, and then it continues on. All right, but for the transformations, let's look at those. So we have 3 on the outside. So we know that 3 is going to go on the outside. Then we have x plus 1 with our x, so e to the x plus 1. And then we're adding 1 on the outside. So we are having a vertical stretch of 3, or by a factor of 3. And then that plus 1, we do the opposite, so left 1. And then plus 1 on the vertical, so up 1. All right, for our points here, if we look at our parent function of e to the x, or our exponential function, it goes through 1, 1, and then 1, about 1, 3. It's not quite 3, but essentially it's going to go through that 1, 1 point, or 0, 1. So it goes through 0, 1, and then 1 is going to be e to the first, and then 2 is e to the second. Kind of you'll go from there. All right. Essentially, you're just curving towards that asymptote, and then your exponential just keeps growing after that. All right, so let's plot our points here. So we have 0, 1, And then we'll have negative 1 e to the negative 1, and then 1 e to the first, and then 2 e to the second. That will kind of give us our basic shape for our graph. And then we know what we have our asymptote at y equals 0. So we'll see how that moves. All right. So that vertical stretch of 3, we'll see that on the points, but remember our asymptotes move by our shifting. So we're going to go left 1 and up 1. So left 1, up 1, kind of at our 0, 1 point. So to the left 1 and up 1. So that's where our center would be. So our 1 is going to be our new asymptote line. And then we're going to apply our transformations to our points. So on the x, we're going left 1, so we're going to subtract 1 from each of these. So we'll get negative 2, negative 1, then 0, then 1. All right, here we're going to be a vertical stretch of 3 and then up 1. So times by 3 and then add 1, times by 3 and then add 1, times by 3 and then add 1, times by 3 and then add 1. All right, so let's do these in our calculator. All right, so let's begin with putting in our first one. Well, this one we can do on our own, so 1 times 3, so we get 4. So at negative 1, 4. All right, and then let's put our other ones in. So e to the first times 3. So e is second divide. So times 3 and then plus 1. So we get 9.15. So at 0, we're kind of up here. And then e to the second times 3 plus 1. We get 23. So that's going to be way off our graph. So it's going to be way up there somewhere. So that's okay. All right, let's do negative. So we might need to do negative 2 here. So plus 1, negative 1, so that'd be negative 3. And then so be e to the negative 2 times 3 plus 1. Just so we can get some more numbers on our graph. All right. E to the negative 1 times 3 plus 1. So we get 2.10. So at negative 2, we're at almost 2. Or a little bit above 2. All right, and then at -2, so e to the -2 times 3 plus 1, we get 1.4. All right, so you'll notice our line here is going to come down and go here. So we're moving that curve. We moved it left one, up one, and then stretch those points farther away from each other. All right, next one. So we're still using our e to the x. So I'll have g of x. So that's going to be 1/3 e to the x minus 1 minus 1. So we have a vertical shrink. So it's going to bring those y values closer together. And then minus 1 is going to be right 1. And then that minus 1 on the outside is going to be down 1. So our same points here, so 0, 1, -1, e to the -1, -2, e to the -2, and then 1, e to the 1, 2, e to the 2. All right. So now we are going to be applying our shifting. So timesing by 1/3 to each of these. And then adding 1 to all of these. And then, oh, those ones then will subtract 1. All right, so on our x values, this is going to be -1, 0, 1, 2, and 3. And then for our values here, so we have 1/3 minus 1, so 3/3, so it's going to be -2/3 here. So we are shifting, so right 1, down 1. So we're moving that asymptote down 1. And then we kind of are moving that other to the right 1 as well. So we're just shifting our values over this way. It's not really an asymptote for that 1, but know that we will kind of be approaching that value there. So we'll put that there. So right 1, down 1. So we're kind of approaching those points here. All right, so let's do some of our examples. So 1, -2/3. So we're going to be close to, I'm going to erase those so we can see our points here. Close to the line here. All right, and then our other points, it's not, there we go. All right, so let's do e to the 1 times 1/3 minus 1. So times, and then I suggest doing your fraction. That is not the correct one. There we go. So do your fractions in parentheses, and then we'll subtract 1. All right, so we get negative 0.09. So that's going to be really close to 0 at 2. Then at 3, so e to the second. And then times 1/3. And then subtract 1. So then we cross, so 1.46. So it's going to be above the line here. And then, all right, and then e to the negative 1. So we get negative 0.878, so negative 0.88 if we're rounding. So it's 0, negative 0.88, so kind of closer to that 1 value. The fraction ones are hard to get here, so let's regraph those. And that line is not quite straight. Let's do this. All right. And then e to the negative 2. We're just going to grab this and change that negative 1 to a 2. So really close to 1, or that negative 1. All right, so then you can see, if we kept going, it will kind of be like this, and we'll go like that. So with our exponential functions, when it has that vertical stretch or shrink, it's going to affect our values and it kind of won't behave how we think it's going to behave. So just watch out for those. All right. It will still, the up and down will still shift correctly because it's that 0 line, you're shifting that asymptote there, but like the right or left, it's kind of dependent on those vertical stretch or shrink points. All right, let's look at our next one. So we have our log function. So if we look at our parent function up here, it's kind of the reciprocal of our exponential function, and we'll talk about that, not reciprocal, inverse of our exponential function. It's flipped upside down, and we'll talk about that when we're in our log and exponential units. But you'll notice here, instead of the y equals 0 asymptote, it's an x equals 0 asymptote. So the y-axis is that asymptote there. All right, and then it kind of has that other semi-asymptote at that point too. So we're looking at our value here. So we have at 1, we're at 0. So see how it's flipped, where this one was 0, 1. That's what that inverse does. It flips the x's and y's. All right, let's look at our transformations now for that graph. All right, so we're going to apply those. So we have a negative log 2 of 2x. All right, that negative means it's a reflect. On the x-axis, because it's on the outside, it's happening to our y values. And then that 2 on the inside, that means we are going to have a horizontal shrink, because remember it's opposite, of 2. So that means we're going to apply 1 over 2 to our x values. Because we do the opposite, because remember we're dividing to get x by itself. All right. So we're not shifting up or down, so we're kind of staying at that point there. And then our points are going to be farther away from each other and flipped upside down. So let's look at our point. So we have 1, 0. So that will still be the same. And then for our other points, if we look at the parent function, so it's log 2 of x is our parent function, or any like log base, that's going to be your parent function. So we have here our log base 2 of x. So we look at our graph. If you look at second graph at the table, notice we have errors after 0, so we do have the asymptote there. So notice, so you have 1, 0, 2, 1, and then 4, 2. So let's keep those points when we're looking at this 2, 1. So we won't use 3 and then 4, 2. That way it will help us with our transformations when we're looking at these. All right. For our x's, we are going to times them by 1/2. And then we are going to look at these and just multiply them by a -1. So we'll have 1/2, 1, and 2. So this will be 0, -1, and -2. So it kind of flips it upside down there. All right. So at 1/2, we're at 0. And then 1, we're at -1. And then 2, we're at -2. So remember, it's flipping it upside down. So our parent function remember, it's going to be this. So it's going to flip that on its side around the x-axis. So we're going to go in this direction. All right, and then if we had 8, so 8, that would be at 3. So multiply that by -1. So it'd be -3. And then this one, so that'd be at 4. So 4, -3. So kind of going kind of like that. So see how it flipped upside down there for your points. So remember when we have those stretches or shrinks that it's going to affect the graph in a different way. So that's why it shifted that value to that 1/2 instead of staying at that one value. It does kind of those weird things. All right. Let's look at our next one. So log base 2 x minus 5 plus 4. So we are going to shift right 5, because remember opposites, and up 4. So for our parent function, remember we're here at 1, 1. So we are going to shift that over. So the right 5, that's our new asymptote there. So we won't be crossing that line there, and then up 4. So we should have a point kind of central to that point there. It's kind of like our 0, 1 point that we're moving to the right 5 and then up 4. All right, let's look at our points. So remember, we'll kind of use those same points here. So 1, 0, 2, 1, 4, 2, and 8, 3, and we'll just shift those points. Now we might not get these other points here because they might not be on the graph. So we only might get a couple. So let's go right 5, so plus 5 on these. And then up 4, so plus 4. All right, so we get 6, 7, 9, and 13. So that one will be on our graph. So then we get 4, 5, 6, and 7. All right, so at 6, we should be at 4, which we have that point there. Then 7, we're 5. 9, we're at 6. 9. And then 13's off the graph. All right, so we are looking like this. That we shifted to the right 5 and up 4. All right. And lastly, we have our equation that we're writing. So we have our 1 over x And then we're remembering our basic equation where A is vertical stretch or shrink, B is horizontal stretch or shrink, C is right or left, and D is up and down. All right, we have a vertical stretch by a factor of 4. So that's our A value. And then our f of x, so 1 over x. And then it says reflect across the x-axis, so that's going to be a negative in front. And then a shift left 4, so that goes with x on the bottom here, so minus 4. So let's regroup that. So we have negative 4 times our 1 over x minus 4, or we just have negative 4 over x minus 4. And that would be your equation. So you're just applying those, same as like we did in 4.3, but we're using those exponential, logs, and reciprocal or rational function. That is the end of our notes. Please let me know if you have any questions. Otherwise, you'll be working on your assignment.